apparatus which is used to investigate the stretching of a spring. On a figure 1.1, measure the length L0 or L0 and record L0 in table 1.1. When load is 0, means when nothing is attached, what we have to do, we just have to use a ruler, a scale, and measure this length. According to paper size, it will be different, but approximately, and this length, in what unit you have to measure, as you can see the table, it should be in millimeter. Like example, if it is 1.5 centimeter, so it will be approximately 15 millimeters. So we'll write 15 here. The second part, explain why L0 is not measured to a point X on the spring. So why we did not measure till point X? Why we only measured for the loops? What is the reason for that? Because basically what happened, these rings are rigid, they will not deform when the spring, even when the spring stretches, what will happen, the spacing between the loops will change as the spring stretch, but the rings will remain same in size even when we attach a load to it. So that is why the spring does not deform or extend or does not show a change in the length. That is why we are not using them for measurement of length of a spring. So why L0 is not measured to point X on the spring? So why it is not measured to the point X of the spring? Because these rings are not, or does not stretch or does not deform or shows a change in the shape. That is why we are not measuring the rings, we are only measuring the length of the loops. The next part, student hangs a 1 Newton load on a spring. He records a new length, that is L. He repeated the procedure using a load 2 Newton, 3, 4, 5. The readings are shown in the table. Describe one precaution that you would take in order to obtain a reliable readings. You are measuring a length. So what precaution you should take when measuring a length of the spring? What should be the precautions? Look perpendicular, avoid parallax error, or because when you add a load, the spring will vibrate as well. So allow the spring to be stationary and then measure the. So look perpendicular, avoid parallax error. Or measure the length of the spring. When it stops vibration. So if the spring is not vibrating, that moment you will measure the length. Then plot a graph for length in millimeter and load. Then when you plot a graph for force and extension, when force is 0, extension is also 0. So force and extension graph, if you are taking force, the load on x-axis and extension on y-axis, force and extension graph or load and extension graph, it will start from origin because they are directly proportional. But if it is length and load graph will not start from origin. Why it will not start from origin? Because when you did not attach any load to this spring, still it is having some length. Like the length of 15 millimeter was there when we did not attach any load. So load and length graph, because even if there is no load, there is a length of the spring. So load and length graph will not start from origin. It will start above the origin. So when we plot a graph for length in millimeter on y-axis and load on x-axis, so what will be the shape of the graph, or how the graph will appear? The values are there. Using the values you will plot the graph, but I'm explaining the shape, what how it will appear. So if you have length which is in millimeter on y-axis and you have load which is in Newton and x-axis, so as you can see, when the load is 0, the length is 15. So means it will not start from origin, it will start above the origin. You will mark the scale. I'm not marking the point, the scale here. I'm just roughly sketching a graph. So when you plot these results, it will be like this, and you will join these points. You will join these points to show a relation between length and load. So what students suggested that the length of a spring is directly proportional to load. State whether you are reading support and justify by reference to the graph line. According to student says length and load are directly proportional. Is he right or wrong? So he's not correct, he's not right, he's wrong. Why? Because the straight line is there, but it is not passing through the origin. So as the graph does not begin or start from the origin, that's why student statement is not correct. So the answer here you will mention the reading does not suggest support the theory or the suggestion because it's a straight line which is not passing through origin. Then use your result to predict the load when the length is twice as L naught. So how you will do this? You have a graph. This is a graph. We want to find a load, the value of the load when L is equals to 2 times L naught. So what is L naught? L naught was 15. So it will be 2 multiplied by 15, 2 multiplied by 15, that is equals to 30. So what you have to do, from 30 on your graph, you will find the value of the length which is 30, and from that value this is a graph line which you will draw. It will come out like this. The question is calculate a load or find the load for which the length is twice as L naught. So if L naught is 15, twice of L naught will be 30. So you will draw a line from 30 and find the value of the load from your graph. And according to your graph, you will write the answer. Is it clear, this part?
Yes, sir.
Because in the question they mention use the result, predict the load L that would give the length twice the value of L naught. So length twice the value of L naught means the length is twice of L naught or 2 times L naught. L naught is 15. So 15 multiplied by 2, that's 30. So what you will do from your graph, you will find when the length is 30, what is the load, and that will be your answer. The class is investigating the refraction of a light passing through a transparent block. A student using optics paints to trace the path of ray of light. Figure 2.1 shows the student ray trace sheet. This is a student trace sheet. You just have, for these questions, you just have to follow the instruction. On figure 2.1, draw a normal at the center of line AB and label the normal as N and L, and label a point E where the normal crosses AB, and label the point M where the normal crosses CD. So what we have to do for this center, the first statement on figure 2.1, draw a normal at the center of side AB. So what you will do, you will measure this length for AB. Like example, if it is 6 centimeter, so 3 centimeter will be the center. So at the center you will draw a normal. So I'm just sketching according to just an idea that is, if this is a center, but in exam you will measure and draw a line, the normal which crosses both AB and CD, and the point where it crosses, label according to what they mention. So draw a normal at the center of AB and label this line as N and L, and label the point E where the normal crosses AB and M where it crosses CD. So this one is E. The point should be visible. So this one is E and the other one is M. And this line N and L. Then the next part, draw a line above AB to the left of the normal at an angle of incidence of 30 to the normal and label this as EF. So what we will do, this is a normal, this is a left of the normal. So we will measure the angle between, using a protractor, you will measure the angle like from the normal, measure angle 30 degrees and draw a line. Draw a line, and what you call this line, you will call this line as E is already there and F point is there. Then label 2 points P1 and P2 the suitable places, a suitable distance for tracing the accurate. So the distance between the pins according to the paper size, at least like 5 centimeter, even 3 centimeter is acceptable. So you will draw the 2 pins, the position of the pins, mark with a cross, and the distance between them should be 3 is acceptable, but 5 will give you more accurate result. So these are the position of the pins which we trace for the incident ray. Is it clear till now? Then what we have to do, the student observe the images P1 in question. In part A, draw a line AB, draw a line above AB to the left of the normal. So this is on the left of the normal. On line AB, we draw the incident ray with an angle of 30. Using a protractor, you will measure this angle and this angle should be 30. And you have to mark 2 crosses on this incident ray which shows the position of the pins. The student observed the image P1 and P2 through a side C and D of the block so that the images of P1, P2 appears behind the other. He places 2 pins P3 and P4 between his eye and the block, and he's seeing P1 and P2 through this. Draw a line joining position P3 and P4 and continue until it meets the normal at K. So what we will do, P3 and P4 are there. This is P3 and this is P4. So what we have to do, we have to draw a line which is joining P3 and P4. So first thing, we do a normal. That was the first part. And it is at the center, and we label the points.
Yes, sir. Your voice is a bit laggy.
Maybe issue with the connection, that's why. Okay, let's see if it persists, then I have to end. So first what we do, I will try to speak a bit slower so that even if it's lagging, it will not make much difference too. So first we do a normal according to the question, and we label the normal as L and N. Then the point where the normal touches the side AB we call E, and where it touches side CD we called it as M, according to the that is in the question you mentioned. Then the second part, they say draw a line left of the normal on side AB or top of side AB with an angle of incidence 30. So what you will do, you will draw a line here, and this angle should be 30 degrees. And this line they mentioned, called this line as EN F. E is already there, so this will be F. Then you have to mark two crosses to show the position of the pins. So the distance between the two crosses should be like 3 to 5 centimeter. Then they're saying draw a line joining P3 and P4 until it meet the normal. So we have to draw a line which is joining P3 and P4, and will continue until it meets the normal. And the point where it meet the normal, what we call this point, we call this point as K. That is according to the question. Because if you see this part, draw a line joining position P3 and P4, continue until it meets the normal, and label this point as K. Now what we have to do, measure the angle, measure and record the angle between a line joining P3, P4 and K and M. So, and that we call that angle as alpha. So which angle we have to measure? We have to measure the angle between K and M and P3 and P4. So what we call that as alpha. So we will write this value according to the question. It can be any number. I'm just randomly, I'm taking a number here. Example, if it was 30. Using a protractor, you will measure this angle. So this will be example 30. Then measure and record the length x between point M and K. So we have to measure a length with x which is between point M and K. So this length we have to measure. This is called x according to the question. So using a ruler, scale, you will measure this. If other lengths in the question are given in millimeter, it will be because other length is also in millimeter. So you will take in millimeter. Example, say it was 20 millimeter. When you measure using a ruler, it is 20. So this is what we have to do. Just completing a ray diagram according to the question and according to the instruction given in the question. Then the next part, the student repeats the procedure with angle of incidence 50 and value of alpha is and x is given. So first what he did, first a student did with an angle of incidence was 30. Angle of incidence was 30. So when angle of incidence was 30 and we calculated the alpha was example 30 and x was 20. Now what student did? Student repeat for angle of incidence 50, he's getting alpha 52 and x is 19 millimeter. A student suggests that angle alpha should be equal to angle of incidence. So angle alpha and angle of incidence are same. State whether the result supports this suggestion. Look, when angle of incidence was 30, the alpha was 30 as well. When angle of incidence is 50, alpha is 52. So are they equal? Are the two values equal to each other? When is angle of incidence equal to alpha? So in a statement we will say yes. How you, because in experimental accuracy, when we say two values are equal, like you have to check out the percentage difference. What is the percentage difference in value of alpha and angle of incidence? So how to know the percentage difference? It is maximum minus minimum, because in practically when I say angle of incidence is 30, even angle of reflection will not be exactly 30, because there are errors due to there are experimental errors, so we have to check a limit of a 10%. So it is maximum minus minimum divided by mean into 100. So maximum value is 52, minimum value is 50 divided by mean or average, which will come out 51 into 100. What is the percentage difference between the two? So 2 divided by 51 into 100. What's the answer? The percentage difference? So it is only 4%. So if it is 4%, and when we are comparing the two values, if the percentage difference is less than 10, less than or equal to 10, we will say the two values are same or equal. If it is more than 10, so within 10%, it is acceptable. So justification statement, what you will say the two values are equal, or the statement is matching with the result. And justification, you can say within experimental accuracy, the two values are same or percentage difference is less than 10. And justification, within limit of experimental accuracy. Two values are equal. So when you compare them, you always compare the percentage difference of the two values, because experimentally, if I say I have one number 4, another time I get the experiment 5, so is it same? So how to work out? Always calculate the percentage difference. The next part suggests one precaution that would you take with the experiment to obtain the reliable result. So experimental results, if you want to make it reliable, so the pin experiment, the experiment which are
Repeat
related,
and find the average.
yeah, so repetition is there. Or the second thing, use or increase the spacing between the pins, use thin lines, use thin pins. The experiments normally which are related to pins, so these are ways to improve. Repetition is there, repetition also, but they're asking for suggest one precaution. Precautionary measure, what you will do, we will use thin lines, thin pins, distance between the pins, should be larger. So greater spacing or distance between the pins will also increase the or look perpendicular, avoid a parallax error. The class is investigating the cooling of a water, means how much time the water will take to cool down. The figure 3.1 shows the apparatus. A thermometer in figure 3.2 show the room temperature theta r at the beginning of the experiment. What is the room temperature according to the reading, according to the scale of this thermometer?
23. 23.
So that is 23 degree centigrade. Then a student pours 200 cm cube of hot water into a beaker. So this is the hot water he added to a beaker. Then she measured the temperature of a hot water in a beaker. Then she start the stopwatch immediately, and after 180 seconds she measured the temperature of hot water, and after 360 seconds she measured the temperature of hot water again. Calculate the delta theta 1 for means the change in temperature for first 180 seconds. What is the change in temperature for first 180 seconds? How much the temperature changes?
11 degrees.
So first one is 11 because the initial was 85 and the final is 74. So when you take a difference, you will get 11. What about the temperature change for next 180 seconds? The difference between,
8.
so that is 8. So first one is 11 and the second one is 8. Then suggest why theta 1 is different from theta 2, means why the initial temperature change is higher, quickly temperature fall, but later the temperature fall is smaller. What is the reason for that, or decreases? Temperature is decreasing, but the rate, with respect to time, the temperature change is smaller. In the beginning, it is
The
faster.
high the higher energy particles move away.
So rate of heat loss is greater at higher temperature. Like if something, like if I say I have two containers filled with the same amount of water, but different temperatures. Like example, this one is at 80 degrees and this one is at 60 degrees. And after say 30 seconds, which one will show a greater change in temperature or decrease in temperature?
The one which 80 degree
80. Why?
absorbs
Because
more.
the first one will show a greater change in temperature because higher temperature or greater difference between the room temperature and the temperature of a substance, rate at which energy transfer will be faster. So the answer, in your own words, you can write suggest why theta 1 is different from theta 2, because theta 1, it is having a greater difference between room temperature and water. So faster rate of heat loss or energy transfer or rate of cooling. Another student planned to investigate the factor affecting the difference between the values of theta 1 and theta 2. Suggest two changes that he could make to the procedure to obtain a large value of this difference. Like
Increase the initial temperature of the water.
increase the initial temperature of the water. Yeah, that's one. Or what else? a student want a greater difference between theta 1 and theta 2, because another student plans to investigate
Yeah,
the
higher room temperature.
higher room temperature or lower room temperature, because when temperature of the water and the temperature of the room, when they have greater difference, then we have a faster rate. So example, if I say this was 80 and the room temperature example 25,
Yeah, sorry, faster rate of cooling.
and another day the room temperature is 20, which one show in 1 minute, which one show greater change in temperature? This, when the room, there's a greater difference between the room temperature and the surrounding, greater rate of heat loss, so rate of cooling will be higher. We want to increase the temperature change, so what we should do, we should lower the room temperature, decrease the room temperature. So increase the temperature of the hot water or decrease the or room temperature or decrease the volume of the water. If you take a small amount of water, then it will cool down at a faster rate as compared to greater amount. Many reasons are there. Even you can use stirring. You can stir, increase surface area. That's one. So room temperature, you can mention increase temperature of water, initial temperature basically, or decrease the room temperature. The next one, the volume of the water used in experiment is measured using a measuring cylinder. So student use a measuring cylinder and measure the volume of the water. Figure 3.3 shows the measuring cylinder. Figure 1, A, B, C, and D are the possible lines of sight that could be used to read the volume. Give two reasons why B is used for more accurate reading. Why B is used? Like A and B both are perpendicular. Why specifically B is used? It is perpendicular to the scale, that's right. And for water, we always read the lower meniscus, because like this is the meniscus. When we read the meniscus for the water, we always read the lower meniscus. And another reason, this side, the marking is on right hand side. So why B is also inaccurate? Because all the marking is on the right hand side. So perpendicular to the scale, we are looking, and we are using the lower meniscus. Okay, the next one, the class is investigating the motion of a pendulum. Figure 4.1 shows the apparatus. You have to, on the figure, clearly show clearly the length of the pendulum. What is the length of the pendulum? Figure 4.1. So length of the pendulum, so length of the pendulum is from the center till the point of the contact. So from center till the point of the contact, this is refers to the length of center of the mass to the point of contact. That's called length of the pendulum. You will mark label as L. Figure 4.2 shows or explain how could you measure. So figure 4.2 shows how could you measure the length accurately and draw on the diagram. So how we can measure the length accurately as possible by using a set square and the ruler? So we should place a ruler closer and place a set square to identify, to recognize the center of this, and we should look perpendicular to avoid a parallax error. So we can read the scale properly. Is it clear? Then a student determines the period of a pendulum. The period is the time taken for one complete oscillation. Student measure the time for 20 oscillations. So this is the time for 20 oscillation. So time for 20 oscillation is 20.22 seconds. You need time for one oscillation. So what you will do, you will divide by 20. So 20.22 divided by 20. Your answer should be in three significant figure. So it will be 1.01 seconds. And then how would you measure the time for, explain how measuring a time for 20 oscillation rather than one oscillation help student to obtain the reliable result. Because what happened when we record the longer time period, it reduces the error due to a reaction time. So when we are recording vibration, it will reduce error in reaction time and average can be taken from the result. Like you're doing it for more swings, more vibrations, so you will have an average result. Then just the value of the t square. So if t is equals to, according to the question, t is equals to 1.01 second. So what will be the t square? So it means 1.01 square. What is the value square of 1.01? Your answer should be in three significant figure. 1.01 square. So it will be 1.02. 1.022 means four significant figures. So 1.02, three significant figure. And the unit will be second square. Is it clear?